Hi, this is Mr. Bauer, and today we want to talk about direct variation. Direct variation is kind of an idea that usually gets thrown into a beginning algebra class when you're talking about slope and slope-intercept form, and kind of throws people for a loop sometimes. And so what we're going to talk about with direct variation is when things vary directly, it really means that they're proportional, okay? Which means that, like, if you increase one, then the other portion of that will be increased in a proportional amount, okay? And so I'm going to be very basic here, and I'm going to start off with the equation that represents direct variation. Anytime I see direct variation, I know that I'm talking about something called y equals kx, okay? Now, for those of you that are working on, have slope embedded in your mind, it's not very different than y equals mx, okay? And that looks a little bit like y equals mx plus b, which is slope-intercept form. And so we're going to find out that slope-intercept form and direct variation are not that far from being the same thing. They're not quite the same thing, though, okay? And the first thing you're going to have to do when you start talking about direct variation is to identify if an equation you're looking at is actually direct variation, okay? So let's see how we would do that. Here's an equation, 4x plus 2y equals 0, all right? Well, you will not be able to tell if something is in direct variation until you solve for y. Hey, isn't that what we do to get things in slope-intercept form? Yes, it is. So let's do that here. Here's a 2y. I don't want this over here, so I'm going to subtract 4x, and then I'll have 2y equals negative 4x. I don't have y by itself yet. What do I need to do? I need to divide by 2. And so then I get y equals negative 4 divided by 2 is negative 2x. All right? Y equals kx. This matches that form, doesn't it? Okay? Yes, this is an example of direct variation. Okay? But you don't know it until you solve it for y. Let's look at one more example. Here's another one. Negative 2x plus y equals 3. Let's solve it for y. We won't know until we do that. So we will add 2x. Y equals, I'm going to write the 2x first. This looks like it's in slope-intercept form. We've just been talking about that, haven't we? But is that direct variation? And the answer is no. It's not because of this plus 3 here. Direct variation doesn't let you put any numbers out here unless you could say plus 0. And so that's how you're going to tell. All right? It could be in slope-intercept form and not be a direct variation. But this is direct variation. It's still a form of slope-intercept form. So solve for y. If you have something extra out here, it's not an example of direct variation. All right? Hope that makes sense. Let's look on at objective number 2. It wants us to graph something that is in direct variation. Okay, so here's an equation or a direct variation. Here we would say that the k value is negative 5, but I want you to actually look at this like it's in slope-intercept form. Okay? So if this is slope-intercept form, what's the y-intercept? 0. And the y-intercept of every direct variation equation will be 0. What's the slope? Well, the slope is negative 5. Make it a fraction. That tells me that I should go down 5. 1, 2, 3, 4, 5. Right 1. And there's my line. Okay? So when you graph direct variation, you will get straight lines just like when we were graphing slope-intercept form, and you can really just do it the same way as you did slope-intercept form. The only difference is here, the y-intercept will always be 0. Okay? That's how you graph direct variation. All right? All right. Now, here's what I would consider the toughest part of a direct variation, and you're going to have to write and use direct variation equations. Okay? All right. Well, here's what's going to happen a lot of times. All right? They're going to start out and say, x and y vary directly. Okay? Now, all that is a sentence that tells you it's okay to use y equals kx here. Okay? And then they'll tell you that when y equals -3, x equals -4. And they'll give you two values. They'll give you a value for x and y. Well, what you want to do is use those values to actually find k. So if they tell me that y equals -3 and x, when x equals -4, I'm going to plug that in there, and now I'm going to try to solve for k. How do you get k by itself here? Well, you divide by -4. And then what does k equal? Well, it equals 3/4. What's a negative divided by a negative? It's a positive. Okay? So when I see this sentence, I know I can use y equals kx. When I see this, I know I can find k. Once I've found k, I'm going to write myself a brand new equation, because they're going to say find something. They'll say find the value of y when x equals 80. Well, now that I have an equation, a usable equation, I'll simply put 80 in for x. And I made it a fraction because this is a fraction. And I'll actually maybe just multiply across the top. That's 240. Multiply across the bottom. That's 4. Take your calculator. 240 divided by 4 is 60. And so really I kind of think there's 3 or 4 steps to this. All right? First of all, knowing that you can use y equals kx, using the two x and y values they give you to find k, writing a brand new equation, and then plugging something into that new equation. All right? That's the step-by-step process you have to go through in order to write and use a direct variation equation. All right? Good luck with that. Talk to you.